Okay, so in this problem we have three different frequencies that are given, and we have to find out whether we have an open pipe or a closed pipe. So to begin, we can see how the waves form in an open pipe and a closed pipe. So as you can see, for an open pipe, as you can see, for an open pipe, you have two antinodes at the end, and then you have one node for the first harmonic, and then for the second harmonic, you have two nodes and two antinodes. So for an open pipe, there's always gonna be antinodes at the end, and for a closed pipe, you will have one node at the end because it's closed, and then on the other end, you can have an anti node. And if you look at the first harmonic and second harmonic, the difference between them is, second harmonic is basically twice of the first harmonic, and for closed pipe it's three times the first harmonic. So the difference between the harmonics in an open pipe is basically the fundamental frequency, which is F1, and for closed pipe it's twice of the fundamental frequency. So if and so in that's one way to verify if we have an open pipe or a closed pipe. So let's look at what we are given. So we have three different frequencies, and if we take the difference between those frequencies, so you see the difference between successive overtones of for an open pipe is the fundamental frequency, as we mentioned, and then it should be an integer multiple. So you see, if you take the difference between the successive frequencies, you will have the difference as 176 hertz. So if we divide to 64 hertz by 176, and we see this is not an integer. So that means this is not an integer. So that means this is not an open pipe. And if it's not an open pipe, we conclude that this is a closed pipe. And so that and so if we look at this line over here, so it says the difference between successive overtones for a closed pipe is twice the fundamental frequency. So if we are claiming this is a closed pipe, we can verify if we are whatever we're claiming is true or not. So if it's twice the fundamental frequency, that means our fundamental frequency will be half of the difference. So if we divide that by 2, we get 88 hertz, and so this should be the fundamental frequency. Now if you want to verify that, we can divide our frequencies by our fundamental frequency and see if we get an integer or not. So if we do that, we get 3. If we divide our 440 hertz by 88, we get 5. And if we divide 616 by 88, we get 7. So in that way, we know that, okay, this is a closed pipe, and we also verified that this is true because we're getting integer numbers by our fundamental frequency calculation. Thank you.